Well, I make it 10 o'clock on the dot Pacific time. So, Andy, why don't we get started?
Great, thanks, Maria. So my name's Andy Rubenus, and we have Maria Colgan as well today. We're going to do another database in memory office hours. I think you can see on my screen we have today's session, obviously, but we'll also have other sessions we've conducted. It's actually starting to get to be a list now, and all of these are recorded, and we're recording this one. So if you want to go back and take a look at what we've talked about in the past, and sometimes we'll reference those previous sessions, so you can go back and watch the recording. In addition to that, if you go to our blog, and I guess I will have to put that URL, actually I think I have it in the links down below here. You can go to our YouTube channel and look at just some of the demos if you want to a refresher, things like how to populate the column store, how to query the column store and see whether or not you used database in memory. And so on that blog, we have the YouTube channel links. And so if you want to go look at that and other information as well. So I think that's my pitch for database in memory office hours and how you can get more information. And again, our session here will also be recorded. I thought we'd do something a little different today. Obviously, if you have questions, please type them into the chat, and Maria will see those and relay them to me, since I don't really have enough real estate to have all of that up here. But I did do a blog post on compression, so I thought we'd focus kind of talking about a little bit about compression initially, and this is actually the blog, so if you want to, you could actually go look at that, the compression blog post that I did. But I thought we'd chat about that a little bit, kind of as a primer, or kind of our focus for today. And then again, obviously, if we have other questions as well, we can answer those. But when I talk to people about compression, kind of the motivation for writing the blog post, and I published this, I think it was the week before Open World, and I used that in the hands-on labs we conducted and also in the sessions we had. And people usually say compression, well, I don't want to do any compression because it'll add overhead. And it will slow everything down, and we don't think it makes sense. But when I ask folks how much memory they can allocate to their column store, usually I get hands raised that maybe they have a total amount of memory in their servers of 256 gigabytes. It's fairly rare, fairly small percentage of folks have 512 gigabytes. Really rare that people have a terabyte of memory in their database servers. And remember, you can't steal memory. So if you're going to allocate the column store and database in memory, that's the in-memory part. You have to allocate additional memory to the SGA for the column store. Because if you steal the memory, I actually talked to somebody very recently about this. If you steal the memory from, say, the buffer cache or the shared pool, likely that workload is going to suffer. And so all of that going around says that most of our Oracle customers don't run around with terabytes or multiple terabytes of memory. And so compression is actually a really nice way of adding the ability to, or creating the ability to add even more objects to your column store. Yes, there is somewhat of a performance penalty, but it's nowhere near what it is if you can't populate those objects in the column store at all. And so that's kind of the focus of today's topic. We do have multiple levels of compression. You can not compress. You can mem compress for DML, which essentially is meant for data that's changing very often. Will only compress the column if all of the values are the same. Not something most people typically will use. The default for query low is a really good starting point, but there are other options. Query high very often can get as good a performance as query low. So you might ask, well, what are these mem compress options doing? And mem compress for query low will do dictionary-based encoding or symbol replacement, and it will also do some run length encoding. Query high will do more run length encoding. All that, you don't really have to know what any of that means, other than to understand that what it means is for database and memory, we can operate directly on the compressed data. and that's pretty powerful. Capacity low and high add a zip-like compression with higher levels. So we get higher levels of compression, but we do add a zip-like compression, so it does add some extra time, overhead, if you will, to decompress, and then we can operate on the compressed data, much like we do query low and query high. So those are the different. Go ahead, Maria. Yeah.
Sorry to interrupt you, but can you, when you say operate on the compressed data, can you explain what you mean by that?
Operate on the compressed data means when you run a select and we start scanning, do table access in memory full, and we start scanning the data, we don't have to do any decompression to actually scan the data. We actually look in each of the IMCUs, and we have a blog post that describes what an IMCU is, an in-memory compression unit. It's basically an object when we populate in the column store will be made up of one or more IMCUs, but we'll actually scan the data in its compressed format, if you will. In other words, we can access the symbol, the symbol dictionary, and we can really just scan that data in its compressed form or its substituted form. We actually also have actually I think you did that as well, a blog post on compression and how we do that with the symbols and the replacement in our blog posts. There is a lot of information on the blog posts. So what I mean by operate on it means that we can actually scan directly on that data. We don't have to translate it. With the capacity low and high, we do have to uncompress each of the IMCUs, and then again, we can operate directly on the other parts of the compression, the symbol, the dictionary encoding, the symbol replacement, if you will, and also run length encoding, which says that we have a whole bunch of values that are the same in the vector. We can actually just compress those down and just make a mark that says, oh, multiple columns have that same value. So does that help, you think?
Yeah, basically I can run the queries on the compressed data.
Yeah, exactly.
Effectively what you're saying.
Yeah, and I say that because that's one of the big advantages of advanced compression as well. But then I confuse people because they think, oh, well, you have to have advanced compression to do database in memory, but that's not the case. Advanced compression is an on-disk segment compression level that we've had around for a long time. Database in memory compression doesn't require anything else. As long as you are licensed for database in memory, you can use all the different compression options that we have for database in memory. It's part of the product. And that sometimes generates confusion as well.
Cool, thanks for that. So I don't have to buy anything else once I've bought in memory.
All for the database in memory, yeah. So let's see, where was I? So those are the different options that are available. And actually, one of the other interesting things is the compression advisor. I don't want to throw too much out there, but the compression advisor also understands these compression levels. So if typically people will ask, common questions are, well, how much memory do I need to allocate for the column store? And how much space will the objects that I do decide to put in the column store, how much space will those take? And the compression advisor understands these compression levels. I guess I can't point, but the compression levels. And so you can actually get a pretty good or pretty close estimate of how much space each of the objects you want to populate, if you want to try that, will take. And so if you want to say, I would like to go, some of my larger objects, I'd like to try capacity high, how much space savings am I going to get? And you can use the compression advisor to do that. And again, those different compression levels you can put in as input to determine that. So there's kind of everything you wanted to know about the different levels of compression and database in memory. But let's get down to, then what I did is I did an experiment, and I took a line order table that was very large, 630 gigabytes. I had our examples today won't be able to go that large because we're going to do something I think is kind of interesting in looking at that. So we will get to some actual SQL queries. But for the blog post, I took a very large table, 630 gigabytes uncompressed on disk, and I populated that in the column store in the various compression formats. And then not only can we see in the chart below here the amount of space that was consumed in the column store, I then ran this query against it to try to get a relative idea of the performance. Now, it's nothing special. It's our normal line order table from our star schema benchmark that we've done our other examples with in the blog and on our Ask Tom sessions. But it does do some aggregation, and it scans the entire line order table for the columns that we specified in the select statement. So we're going to look at everything, and we're going to have to scan multiple columns. So it does some work. And so I kind of wanted to see, okay, so what are the performance penalties we're getting with that? And as you can see in the table here, I took each of the compression levels, including not compressing it at all. And we went, with the default, we got 339 gigabytes. And at capacity high, we were down to 138 gigabytes. So we got a significant space savings with capacity high. Now, nothing in life is free. It does come with a penalty. It's going to take longer to query. But I did mention in the somewhere in here that with it uncompressed, fully cached in the buffer cache, it took an incredibly long time to scan that same query. Now, you could argue that you might put some indexes on, you might you might have a where clause predicate, but the bottom line is the time it takes to query the data with it, even at capacity high of 12 seconds, is way faster than you're going to be able to do that in the buffer cache or the row store, unless you fully index the query. And granted, my query is very simple, so you don't really want, if you have to create indexes on all of the columns, then the space it's going to take and the overhead for DML is going to be so high that the going to paying a slight penalty in the query on capacity high is really noise compared to the space savings you get. And that's kind of the gist of this, because again, people will think that if I do compression, it's going to be so much overhead that it doesn't make any sense. And kind of the point is, well, it does make sense, especially going back to what we originally said, is that if people that don't have gobs of memory on their database server, they can't allocate a terabyte of space to the column store because they don't have a terabyte. They might have a much smaller memory footprint. And so with that said, that's kind of was the topic in the gist of the blog post.
So Andy, it's interesting to see on the numbers you've just shown us that although we saved twice as much memory with capacity high, the query didn't take twice as long. So you really are getting a lot more bang for your buck, as you said, because we saved an awful lot of space with a capacity high, and it didn't take us very long to execute that query at all.
Yeah, I think I did. I tried to do some math, which is always dangerous for me. But basically, I said that the worst, at capacity high, we got about a 37% performance degradation, which is significant, but compared to not having it in memory. But we got 2.5 times the memory capacity, which is huge. So the cost benefit there is definitely worth considering, because you're already way faster. And think of if you could get 2.5 times more objects in the column store, that could really make a big difference in your analytic workload or reporting workload.
Right. And I mean, if I look at the non-compressed number, it's still slightly higher than the capacity high. So I'm not losing that much in terms of performance. Of course, it is, as you said, quite a bit slower than if I go with the default. But as you said, then the advantage is I can pack way more objects into my column store and actually have even more of my analytic workload covered by in-memory, which I think could certainly be worth it for folks who don't have a terabyte hanging around just for their in-memory column store.
Yeah, definitely. And actually something I probably could have put in the blog, but maybe it'll be part 2, because we've talked about, and we talked a lot of open world about automatic data optimization and the new feature in 18C called AIM, automatic in memory. And one of the features there is saying that, well, for objects that are getting queried, but not queried really often, but they're still analytic workload, you might have different objects at different compression levels, and those two features can actually help you do that automatically. And so all of this kind of fits together. Database memory leverages other features of Oracle database, and then database memory has additional features to manage all of these things. And so it's not, one size fits all. Different objects may have different query requirements. So Yeah, it's kind of all fits together, and actually that would probably be another good blog post, would be to tie all that in, because that is one of the features of those ADO and AIM, is to be able to do, rather than just evicting an object, compress it at a higher level, still get the benefits of database in memory. Yeah, it won't be exactly as fast as it was at the default level, but it's still way faster than the row store, and you don't have to index everything, which is another huge benefit.
So Andy, just so I make sure I understand, so you're saying that Oracle will automatically take care of this for me, that I'm not even going to have to worry about it myself?
Yeah, the automatic in memory on 18C, which is a new feature with the addition of using heat map data, which we introduced back in 12.1 with the initial release of ADO, can automatically decide, do these objects, based on their access to heat map, we could make those higher compression rather than evicting them. And so that's where we're headed with database in memory in future releases, is to try to make the management of the column store automatic. Not autonomous, but automatic. So, and actually, hopefully that'll allow database in memory to fold into some of the autonomous database options, because we'd like you to be able to take advantage of this without having to do anything. And that would be the kind of the holy grail of the promise of both autonomous databases that you're talking about a lot, and database in memory as well, so that you don't have to decide, you don't have to run the in-memory advisor, you don't have to decide what objects to put in the database. The database will figure that out for you.
That's great.
So let's switch over. So what I've done is hopefully this will work out okay. I have a SQL Plus session into a database that I've loaded, and what I did, which I think is kind of cool, is hopefully we can avoid too much typing so I don't mess things up. But what I've got here is our SSB schema. What I've done is I've created multiple line order tables. So I've created a line order table, the very first one there, tried to sort this a little bit, but the very first one there is just the default line order table for query low. But what the interesting ones, when we'll spend most of our time on, is I have another line order table, also query low. I'll talk about in a few minutes why I have two of these line order tables at the same default in-memory compression capacity. Then I did one at query high and one at capacity high. So the only difference between the tables is I changed the in-memory compression level when I populated them. So I already populated them. So let's take a look at that. And that one is I am populated, kind of makes sense. And so I've populated the tables. And then again, we'll talk about the line order table in a few minutes, because notice that it didn't get fully populated. But our query low, our query high, the first two, and our capacity high, the CH one, are all fully populated. And notice the in-memory size kind of follows what we did with in the blog post. You see that query low is about 7.5 gigabytes in memory, and query high is only 3 gigabytes, 3.2, but 3 gigabytes. And then capacity high is only 2 gigabytes. So look, I mean, that's a lot. From 7.5 gigabytes to just over 2 gigabytes of space. And that's kind of what we're talking about. Now, this is the line order table from our SSB schema. Your mileage is going to vary. You need to run these tests on your data. Compression is definitely one of those things that's very data dependent. But as an experiment and kind of a teaser, if you will, for you guys to perhaps go try this on your data, using capacity high is a pretty significant space savings.
Definitely. Andy, one quick question. I noticed there that your line order has a lot, the one that's just called line order has a lot of bytes not populated.
Yeah, I did that for, we're going to talk a little bit about, in a few minutes, I think we'll do one on, well, what happens if all my data doesn't fit? If I had compressed that line order table to say query higher, capacity high, it would have all fit, or could have all fit. And so and actually it would have fit if you look at the in-memory size that's actually made it in. It could have been capacity high, and we would have all fit it in. So then the question becomes, well, what happens if I then query on that data? What's the difference in the query speed? But I put it there so we could do some comparisons. So I'm going to ignore that initially, but that's why I did it. And thank you for pointing that out, because yeah, if you look at it, the total in-memory size is larger than if it was capacity high. So it would have fit if we compressed it to capacity high, but since I took the default, it didn't fit. 6 gigabytes of it didn't fit in, and we see that if it had all fit, it would have taken 7.5 gigabytes. So we're going to table that for a minute, but I will. That's why I did that. But I didn't want to take the time in our session today to populate it and wait for it to populate. It's fairly quick, but it just introduces a variable that when you're doing a real demo, I didn't need to have that variable there. So what I've done is I actually created some queries. And so let's take a look at how fast we query based on QL, which is query low. And it's going to be fast. It's basically half a second. And we do our table access in-memory full. So this is similar to the queries we run in our hands-on labs and our by example presentation. So you can see that, yeah, it was accessing in-memory. And then we can take a look at the statistics to see that, yes, we scan the column store. IM scan rows are it's actually roughly 73 million. And we accessed it. Mem compressed for query low is what our IMCUs were compressed at. So bottom line is that it ran in half a second. It was pretty darn fast. So I also have the query for query high. Notice in the SQL query, I just specified line order underscore QL. And then we'll do query high, and it runs slower. I mean, it does. It runs and takes 4 seconds in this to run. Again, table access in-memory full. It's a different table. And we're still doing all of our in-memory access. But it took 4 seconds versus half a second. So you are paying a performance penalty. And then I also have capacity high. Now, what's interesting is the difference between query high and capacity high isn't that much. When I said sometimes customers it's data dependent, because there's cases, a lot of cases where we found where query high is actually faster than query low. Of course, the line order table and those particular columns we're querying aren't giving us a lot of benefit or any benefit. They're actually causing a little additional time. But notice that the capacity high, where I said we do a zip-like compression and we got significant space savings, isn't much slower. It's only like a half a second slower. So it really does depend on your data, but the point being that you're not paying a huge penalty to get a significant space savings, or space savings versus performance with capacity high. And again, querying the capacity high, notice that it says IM scan mem compress for capacity high now, not low or query high. And so we're still the same number of IMCUs, but it's just kind of an example. And I'm right up front about your mileage will vary. Let's see, where did my QL go? Query low. That's 4 seconds. 0.56. I mean, it's faster, but let's take a look at, I did do a fully cached in the buffer cache, the same table. We're going to query low. Notice our no in-memory hint. We've talked about that before as well. So we're going to just, if it was, and it is fully cached in the buffer cache, I'll show you the statistics. What I did is I created a keep pool, and when I populated this table, I also had it go into the keep pool fully cached. So it's an apples to apples comparison. That takes 20 seconds. So even if you're at query high, or I'm sorry, capacity high, taking almost 4.5 seconds, a little more than 4.5 seconds, compared to 20 seconds in the row store, that's huge. And we got a huge space savings as well. And then notice that it says table access full, line order QL. and no physical reads. I had to double check to make sure we got it fully cached in the keep pool, but it's all session logical reads. And so that's a significant savings. And I usually use this kind of a comparison in our hands-on labs when I show, well, because people will normally ask, well, if I just put the data all in the buffer cache, it's fully in memory, what's the big deal? It should be the same speed. And it's clearly not. Even at capacity high, it's not even close.
So that's great that you pointed that out. That question just came in on the chat. Eric was asking how much faster would this be over not having it in memory at all. So I think you're doing the fairest comparison here by comparing it to row format in memory, so that we've taken I/O completely out of the question, Andy. But it's quite obvious that there are a lot of benefits being had from the in-memory column store above and beyond just having the data in memory.
Right. And we've talked about that in our previous sessions, and we talk a lot about that in our white paper and in the sessions I do at conferences. All of the things like SIMD vector processing, compression, obviously, which is what we're talking about now, in-memory storage indexes, which actually we're going to visit in a few minutes. But yeah, so there's definitely, it's not, I usually tell people in-memory is an enabler. It's really the columnar format and all of the technical features that we've built into that columnar format. Plus, can't forget that the optimizer is our friend as well. And so it also understands that the columnar format and how to leverage that. We did a hash join session previously where we talked a lot about that. I think I'm going to do a vector group by in-memory aggregation session to explain that, because it is very interesting that the optimizer can also enhance performance of database in memory. So do we have, should I stop? Do we have other questions we should tackle first? Or
so there's a couple of more questions. IoTs, are they still not supported even in 18.3 was another question that came in.
Yeah, index organized tables still not supported, but we are working on it. So
okay.
I don't know what release it will be, because index organized tables are really an OLTP, very fast lookup type
right.
structure, but we are actually looking at placing those in the column store and giving you even faster performance with them. But they are currently not supported in the column store. Basically, index organized tables, hash clusters, and out-of-line lobs are not supported as data types in the column store. Now, they're certainly supported. In Oracle database, you could still have a table populated in the column store that has those objects, but those won't be populated. Well, not hash clusters in index organized tables, but the out-of-line lobs we will populate, but we won't populate the out-of-line lob.
Another question that came in was about what type of where clause predicates get the best benefit from the in-memory column store, and whether or not a like predicate where you're looking for a subset of a string would see some benefit from the in-memory column store.
Yeah, so like predicate will see benefit from the column store. The qualities are the best because then we can take advantage of our in-memory storage indexes, the min-max pruning, if you will. And we're going to take a look at that. And like I said, well, assuming we don't have too many questions, but that's okay. I'd much rather get everybody's questions answered. But yeah, I do have an example that shows a little bit about that. What currently won't make use of the where clause predicates won't be pushed down, if you will. We did a push down blog post a while back about what can be pushed into the scan. I tend to tell people that the ultimate database in memory query is one that where all of the work of the query is done in scanning the objects, and we don't have to do anything else. Things like PL/SQL functions. We can't push PL/SQL functions into the column store. That doesn't work. Mostly aggregations and equality predicates will work. Betweens will work. We're working to expand that. So, something that's coming in the next release is a fairly large amount of work that's been done to make even more filter predicates. It does depend. There's so many variables that the kind of cool thing is you can test it yourself. So you can see the pruning that might occur or the speed difference even the execution plan will tell you whether we were able to push that filter predicate into the column store in the predicate section. So of like a DBMS X-plan, I don't have a filter predicate here, but we have examples of that on the blog. We've talked about that. So there are kind of the rule of thumb, or the easiest way to think about it is we'll push simple aggregations like mins, maxes, counts into the scan of the column store. And equality predicates we'll definitely put in there. Likes we'll put in there. But we won't do really complex predicates and like PL/SQL. And so we are working on seeing if we can do something with that. But if you think about it, we're scanning all of the columns or columns that you've placed in both your select statement and your where clause predicate, and we're trying to scan that very fast. If we have to break out and look for other values somewhere else, then it doesn't make sense because it kind of defeats the purpose. So that's kind of the thinking there, is that basically it has to be contained within the columns we're looking at, in addition to all the other issues of PL/SQL, if you will, and doing kind of if then else's in the midst of a column scan. Kind of doesn't make sense, kind of ruins SIMD vector processing and other issues. So we'll always be somewhat limited in that aspect because, again, the idea is that we're scanning billions of rows per second per core. And so leveraging things like SIMD vector processing. So we're not going to be able to do complex predicates during the scan. Now I say that, and the magic of the developers will, at some point, somebody will come up with a method, but initially, at least in the current releases, we don't do that.
So one last thing that is more of a wacky idea is how Eric has phrased it. But the question is, can I combine Oracle text with Oracle database in memory to do, I guess, faster text searches?
There is currently the metadata, so it's kind of convoluted. It's kind of a byproduct. There is a metadata, and to be honest, I don't get to ask that very often, and I don't know, maybe you remember, Maria, but there is metadata associated with Oracle text that will get pushed into the column store, but the basic searching, other than just normal searching across like a like, but as far as the context, the index itself, it doesn't get leveraged by database in memory.
Yeah, it's something that I've meant to talk to Roger Ford about. If we put the underlying tables that belong to the text-based index into the column store, whether we see some benefit on that or not. But it's certainly not something that we actively do today.
Yeah, there's a blurb in the documentation that says something to that effect, that we do partially leverage it. I've talked to them, and for all intents and purposes, though, it doesn't leverage the actual is it context or intermediate index that gets created as part of that.
Right.
We do, though, and we are working even more with the spatial guys. So we are trying to expand the different data types that database in memory will support. So some of the SDO geometry stuff, which I don't remember off the top of my head, all the different aspects of spatial, are also being worked on to add into database in memory. Because you think about it, analytics on locations and spatial actually does kind of make sense. So,
right.
Yeah.
So anyway, sorry for the interrupt. They were the questions we've gotten so far, but we'll let you get back to the demo.
Yeah, so let's see. I remember where I was at. We talked about compression in general. We talked about the space savings, kind of showed you that. We've now run some queries on the different levels of compression and a row comparison, just in the fully cached in the buffer cache. The other thing, I had a couple other things I wanted to talk about. One was, let's go back to the partial population. So if I rerun our populated query, and Maria, you asked about, well, okay, so why did I put this in here? Notice we didn't get fully populated. So we already know how fast the capacity high query ran, like 4.8 seconds. And so I have a query here that's going to access that partially populated table, the standard liner. I don't have a QL or a QH or a CH on it. And if I can, it was the partial one. So now we're going to query that. So say we didn't have enough space. We didn't do compression. We didn't put capacity high on it, which we didn't. And we're only partially populated. And so what kind of penalty we perform there? We already know, because we've talked about this, it's going to run because Oracle database won't fail because either the object isn't populated or it's only partially populated. But notice it took 13 seconds to run. So we accessed some of the data in the column store, and let's take a look at that. So since we access some of the data in the column store, we get table access in memory full. But in the statistics, notice that our scan rows, the other queries had 73 million, because that's how many rows we had in the query. Here we got 26 million of those queries, or sorry, rows from the column store. And notice this new statistic that shows up. Table scan disk IMC fallback. Whoops, there we go. And so the rest of the rows we had to get from the buffer cache. And so we paid the penalty, because remember when we did all of them from the row store, it was like 20 seconds. And so now we got some benefit, but not as much benefit. If we had done capacity high, it would have run in 4.5 seconds versus 13. So there again is the one of the benefits of just saying, well, it's better to have it compressed at a higher level than not have it there at all. And that's kind of the other kind of thinking where I'm trying to get across with the whole post and then, of course, this session. One of the other questions I know you're going to ask, and that people ask me all the time, is, well, what happens if not all the columns I'm querying are in the column store? So say I got it all in the column store, but I decided to exclude for some reason quantity or order price, or maybe some other column I decided to query on. What happens then? And the answer to that is it's all or nothing in that case. So if you query a column that you've excluded, which we allow, and I actually did a blog, I had to go back and look, I did a blog post, questions you asked, actually fairly recently, I revisited this, and we'll have to go to the row store. So if you exclude columns because maybe you didn't have enough space, and so rather than doing compression because, oh, that's going to be too much overhead, I'll just exclude columns. Perfectly legitimate thing to do. People do it all the time. It's a great way to save space because there's no point in populating columns you're never going to access. But if somebody does decide to access that column, we're going to go to the row store. You don't get it both ways. Although, with that said, we are looking at a feature we call hybrid. So you get all sorts of new teasers here, but we're looking at hybrid queries, which will then, the gist of that is it will access the data in the column store, and any column values we don't find, we'll try to get those we'll get those from the row store and make those more efficient. Now that's something we're working on. It's no promises here, but that is, we understand that those issues do come up, and we are looking at if it's feasible to do that. Originally we didn't, because we decided it didn't make any sense because it was going to be too slow. So the developers are trying to work some magic and see if maybe that is possible to do to help leverage the ability to still run an in-memory query, even if not all the columns are in memory.
I mean, effectively use the in-memory column store as an index then to filter down just to the rows that I need to answer the query, basically.
Exactly. And then go get any missing columns. So most likely you won't be able to have missing columns in the where clause predicate because that's the indexing part.
Right.
But then if you maybe had a column or columns in the select part of the statement that weren't included, maybe we could go get those. Because if you think about it, most likely the number of rows coming back is going to be very, very small. Analytic type queries, we're doing aggregation, we're doing filtering, and it might make sense versus having to go to the column or the row store for all of the data. So.
Okay. One other question on the example that you just shown where not all of the rows were in the in-memory column store. One question I get commonly with that is the fact that the execution plan said in memory.
Right.
Do you want to talk just a little bit about what that keyword in memory means there in the plan as opposed to what we all think it means?
Sure. So if we've enabled an object for in memory, then the cost-based optimizer is going to assume that that object's in memory. It will parse, at parse time, it will take a look at the statistics associated with the object. But in this case, it's decided that and it actually proves out that even though it was only partially populated, so the intent is that the optimizer is going to access this object in memory. We don't have an access path that says, well, we're going to go half in memory and half at the row store. That doesn't have. Plus, if you think about it, there are other situations where we could be here and maybe we're in the middle of population. So maybe you ran your query and at the time you ran it, it was only partially populated, but eventually it's going to finish populating and it'll be fully populated. We don't prevent you from running the query. We say that we'll get the data that's in the column store, and then the rest from the row store. So there are other situations, or the table could have grown, whatever. There are other situations, not necessarily static, but dynamic, that could result in the fact that the optimizer is says it has enough to make an in-memory full access path. But as we see here, it's no guarantee that everything's going to come from in-memory. And you can validate that. We've said that since the beginning by taking a look at the session level statistics, which is what this is. So in this query, all I'm literally doing for this section of it is I'm querying VDollar/MyStat, or session level statistics, and I'm querying all these different statistics. Now you don't see them all because if the value is 0, there's no point in listing it. But that's a way to go back and say, yeah, we leveraged in memory. It definitely was faster than if we had just gone to the buffer cache, but it's not as fast as if it was fully populated. And you're not in a situation here where if a column was missing, we had to go to the buffer cache. We actually can access the row store just for the data we have to get to complete the query.
Okay, so lesson learned that if I
no
see...
long-winded answer.
No, I mean, if I see in memory in the plan, it's only an indication that some or all of the rows will come from the in-memory store. There's no guarantees It's all coming from the in-memory store. And I guess looking at the session level statistics is truly the right way to determine if I got my entire result set from the in-memory column store.
Right, and as you well know, it's because we're not going to allow a query to fail. We want the query to run successfully. It may not be as fast, but it's going to run successfully. We're going to get a read-consistent view of the data. We haven't changed the Oracle transaction mechanisms at all. That architecture remains, and so Oracle has made its bread and butter on giving you most accurate results based on when you run the query, so you get a read-consistent view always of the data. And that may be that that data is not all in column store, and so the query still runs, you still get the right result back, and this is just a way to tell. But again, in the access plan, we can't say at parse time, because we also, we reuse queries. We don't have to reparse every time we execute a query. And so at that point in time, it's going to access it in memory full. And we don't say, well, but we're only going to get maybe a third of it from the column store and 2/3. That just isn't practical. So yeah, it's an indication, right? So.
Yep. No, it makes sense.
Or intent, maybe that's a better word. Yeah. All right. So the last thing I had that I kind of wanted to cover, which I get periodically, and the folks that are paying attention will kind of say, well, okay, wait a minute now. What if I just index this? Would it be just as fast? Does the compression affect that? And so here's kind of my take on that. And so I've got an index comparison script. This is basically one that I run in the hands-on labs to answer this question. And so I've got an index. I'm going to make it visible so the optimizer can make use of it. It's set invisible, but I'm going to tell the optimizer it can use invisible indexes. So we're going to run the query against the QL, the default compression level in-memory table. And I'm going to say, I'm going to give it a filter predicate so it can make use of the index. And cross our fingers, yes, it used the index, because that would be bad for my demo if it didn't. And we see that it ran, whoops, I went flying by the speed, where'd it go? So it ran essentially instantaneously, 0.00 of a second, within the margin of error of basically being really fast. But it used the index because the optimizer decided in our case, we got a single row back. It made, we got a single, single row back. That was the fastest way to access that data. Now, the interesting part of that, usually what I show in addition to that is, well, that's true, but, and there's always a but with computers and Oracle database and that kind of stuff. So I have, here we go, IM key QL. So what if we don't have access to that index, but we're going to run the same query? This is query low, so this is the default compression level you would normally do. And this is kind of basically the same query I'd run in my hands-on lab. And 0.01, so that's a teaser. We're going to do in-memory full. Here's, by the way, in the filter predicate information, how you can tell if we pushed that filter predicate into the scan, which we did. But what's interesting about this, and something we talk about, is notice that we actually pruned a bunch of IMCUs out of our query, kind of like what an index would do in scanning and getting a row ID out of the index structure and then accessing just the row ID of the table rather than having to do a full scan. And we ran basically, that's kind of a wash in my opinion, as far as CPU used and response time of the query. And so the second query I had was, so we talk about that, and in-memory storage indexes can provide as good a performance as an index. But remember, when we populate an object, we do all of that automatically, and we don't generate any undo, redo, or we don't take any disk space to maintain any of that. Whereas with an index, all of that is true. It's a persisting object. It's part of the row store. If we have to recover it, we have to recover the index along with the table. Many times, mature applications will have as many indexes or take up as much disk space for indexes as table data. And it's actually relatively expensive, even though indexes are very efficient. It's relatively expensive for DML to maintain lots and lots of indexes. It takes a lot of overhead as far as the transaction goes to maintain the index, to do any block splits if necessary, to generate undo and redo to make sure it's recoverable, blah, 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 blah. And so with database in memory and in-memory storage indexes, it is possible to come close or even essentially do the same speed as an index access would. So it's not always as clear-cut as people might think. And the other point of that was, well, what happens if we look at our capacity high table with the same thing? Notice we ran it 0.01 fast. We use only 0.06 of a second, I guess, with CPU, or I don't remember what's that values. I think in session statistic level, it's 0.6. It's hundredths of a second, and then
hundredths of a second, yeah.
Yeah, I haven't had to think about that for a while. I don't look at that many extended SQL trace files anymore. So, but we are in it today. It does take a little bit longer, but pretty darn fast, even with capacity high. Notice I have our _ch, and we're still pushing that filter predicate in, and we're using a little bit more CPU, and we're accessing our IMCUs capacity high, but we still pruned, so in-memory storage indexes still work. And so now if you think about it, if you're not scanning all of the data, if you actually have filter predicates, which most people do, and if you're able to skip over these compressed IMCUs, so you're not having to access all of them, then it becomes even closer, because the original test I did was scanning all of the columns, the 2-column values we had, all the IMCUs. Now we're saying, well, but when we push predicates, we can actually prune some of those IMCUs. So now the performance difference becomes much less. And actually, this would be another good thing to put in a part 2 of the compression blog, which I hadn't thought about. So that's what happens when you start putting these kind of things together. You start thinking about all the other variables. And now capacity high doesn't seem like such a bad idea at all, because the performance is really close. And remember, we got a 2.5 times space capacity increase. So there you go. So it's not as clear cut as you might think when you first think about, oh, compression. It's going to be so much overhead to do that. All right, I think I'm almost talked out with that.
All right. Well, I mean, I think you made a great point, though. We don't think about, when we add indexes to a system, we don't think about the overhead of those indexes. Yet when somebody makes a suggestion of like compression, the very first thought is overhead. What is the overhead of that? We don't necessarily think about the performance benefit we're going to get by compressing the data, but I think the numbers you showed us today really prove out that being able to put more objects or larger objects into my in-memory column store and using that potentially instead of having to index older data may actually be a much more efficient use of my resources and overall performance benefit for my application.
Right. Yep. Yep. That's yeah. Good. That's kind of the point, and this one is actually pretty persuasive, I think, because realistically, when you start adding in filter predicates and joins and maybe key, vector group bys, then all of it starts to blur a little bit more because now the actual scan of the INCU isn't necessarily, or maybe the decompression if we're capacity high, isn't necessarily the largest component of the transaction time. And as we've learned from others in the industry, that's kind of where we want to look, as where the largest time consumers are. And if you're gaining that much more memory, which we've already kind of talked about being at a premium for most Oracle customers, then this makes, I think, a lot of sense. So I saw some flashing there. Do we have?
Yes, so we do have a question. Sorry. So first off, Eric wants to know if I've never used in-memory column store before, but if I try it and I don't see any benefit, can I easily disable it again?
Yes.
Effectively, how can he turn it off? Yes.
So allocating the column store in-memory underscore size, that's an instance-wide parameter, and so that's going to allocate the memory. But where you're not going to, that's just memory that's allocated. So it's the alter table in memory or the partition, subpartition, or materialized view. Can I disable that? And there's multiple ways to do that. You could certainly just do an alter table no in memory, or you could disable the in-memory query either at a, there's an initialization parameter, you do it at the system level. So even though it's populated in the column store, nobody will use it. The optimizer won't consider that as an access plan. You can do it at the session level. You can do it at the hint level. I think in the row query one I did, I had a no in-memory hint in there, so we wouldn't use the column store. So the answer is yes, but again, it wouldn't be Oracle if we didn't give you lots of choices or ways to do that. So yeah, there are multiple ways to prevent either the use of the column store or for various reasons. So.
Okay, and so then the other question that came in earlier today, and there's been some follow-up on it now, was about if I don't have enough memory, will Oracle take advantage of Flash in order to be able to still use the in-memory format, but on a larger volume of data? Do you want to spend a few minutes chatting about that? Sure.
I did do a blog post on this so that if you, because gets a little confusing only in the sense that on Exadata, Exadatas typically have a lot of flash. And so starting in the 12.2 storage server software, you could still actually run a 12.102 database on the compute side, but in 12.2 of the storage server software and then in 18C, we've added the ability to have fully database in memory formatted data in the flash, in the flash cache. So that gives you the ability now to extend the column store, if you will, to terabytes of data. Initially in 12.2, we only supported HCC objects that had been smart scanned, and then we would populate that data into the flash. In 18C, we extended that to all of the data, whether it's HCC formatted or not. And we've backported to the 12.2 storage server software the ability to have non-HCC objects as well. The only caveat is in a completely automatic, although it requires that you have in-memory underscore size enabled. So you have to be a database in memory customer, which in the cloud on Exadata is no problem because it's all included. On premises, you'd have to make sure you license database in memory. But all objects then that aren't populated in the column store are eligible based on being smart scanned to then be populated in the Exadata flash cache in true in-memory columnar format, which means SIMD vector processing, storage indexes, And so I like to tell people that it's a great way, especially for folks that are consolidating or have very large analytic workloads, to deheat their I/O subsystem, because now you're not having to go to disk. Even though Exadata is really fast, smart scans are very, very fast. They really are. They're scary fast. They still spin up the I/O, the disks. And so if you can avoid doing that, it just further expands, both it gives you the ability to do columnar analytics in Flash, and leverages even a larger capacity I/O workload than you would have otherwise. So it's kind of like, say, it deheats your I/O subsystem. So I have a friend who likes to talk about rust and things, and deheating was his term. And so I think that's a great way to think about it. So so that's all controlled by the storage server software, because the Flash is obviously on the storage servers.
Okay, and a follow-up to that, can I tell ADO about the Flash, or can I basically get ADO to automatically move some objects out of the in-memory column store and onto Flash?
Not yet. But if you think about it, if you evict an object from the column store based on a policy, and then it's smart scanned, it will then automatically go into the Flash cache. So in essence, you kind of do, but not directly. You don't there's no policy currently that says I want to tier to the Flash cache.
But I could have two policies, right? I could have a policy that says remove it from the in-memory column store when it's 30 days old, and another policy that says give it the cell memory attribute after it's 30 days old. I guess I could manually do it, right?
You could do a PL-SQL one, but the only reason to do that would be if you wanted to go to a higher compression level than the default for the storage cell, because all objects are eligible. So the cell memory, Roger corrected me on this, the cell memory is really only so that you can add attributes that aren't the defaults. The default's always going to be to, when you smart scan an object, to push it then into the columnar format in the Flash cache, assuming you have in memory and assuming all the other caveats.
Okay. Then there's been some questions about what about using in memory on Active Data Guard for an on-premises database installation? Will it be allowed?
If I had a good crystal ball, it would be I would be probably not doing this and would be doing something different. But currently, you cannot, and obviously the person understands that, you cannot use database in memory on Active Data Guard. It has to be in the cloud or on Exadata. And so I don't see that policy changing anytime soon. And that goes all the way up to the top, if you know what I mean.
So if I'm on 18C though, and I'm on premise, as long as I'm on an Exadata, then I can use the in-memory on the Active Data Guard standby.
Yes.
Right? So I'm on premise, but I've got Exadata. Right. Or if I'm in our cloud environment, I have that ability.
Right. And actually it works if you're on premises for your primary database, but you put your your standby database in the cloud, that will work as well. So it's got to be the standby's got to be cloud or Exadata. And gosh, I hope I don't screw that up, because the licensing for all these different features. But that's the gist of it. You can actually have the primary on premises and then the standby in the cloud. So if you're doing your disaster recovery and you're using the cloud to back that up, because you don't want to have mirrored hardware because it's expensive, hard to maintain, blah, 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 it's very viable to do that in the cloud. So.
Okay, great.
And of course, if you ever have questions about those kind of licensing issues, my caveat, my way out of this is that always refer to the licensing documentation, the licensing guide, because that will be the ultimate arbitrator of whether it's supported or not. So I think I've got all that right, but I always like to make sure that, that's ultimately what I say doesn't really matter, because that's what will be the final, which but our other customers might not. So.
All right, sounds good. It looks like we have gotten to the top of the hour, and we have managed to address, I believe, all of the questions on chat. We want to take an opportunity to thank folks for joining us today, and Andy for that fantastic session on database in memory.
Thank you. It was a pleasure. And remember, we'll have a recording of this on the Ask Tom website, and I will probably carve this up into a nice, hopefully a nice demo on our YouTube channel. And if you do have questions about database in memory, feel free to either email me or make a comment on the blog. Again, we have a compression blog post where this topic might be applicable. And don't forget that the blog has lots of information about database in memory. And with that, thank you very much.
Thanks, folks. We'll see you next time.
Bye-bye.